Okay, so for this one, it says the value of a car, C of t, is, value of the car, C of t years after 2011 is modeled by the following function. C of t is equal to 50,000 times 0.9 raised to the t minus 2,000. So the car depreciates approximately about 10% every year, but automatically right after you drive off the lot, the value goes down to 48,000. Right? So the car is worth $50,000. How did I know? Where did I get that 48,000 from? Well, right, if I say C of 0, I got 50,000 times 0.9 raised to the 0, okay, minus 2,000. What is anything raised to the 0? Can somebody tell me? No? Anything raised to the 0. What does that equal? No? No. Let's plug it in our calculators. Turn your calculators on. I'm surprised. We've gone over this so many times, but so turn on the calculators. It quit, and then I just want you to do 0.9 raised to the 0. Hit enter. Now I want you to hit 2 raised to the 0. Hit enter. I want you to do 3 raised to the 0. Hit enter. I want you to do 999 raised to the 0. What do you notice? They all equal 1. Now, if I do negative 999 and raise it to the 0, what do you notice? But essentially, actually, I did that wrong. If I were to do like if I do this, I entered that one in the calculator wrong. Now it'll be positive 1. So anything raised to, if it's in parentheses and it's raised to the 0, it's going to equal 1. Okay? So this whole thing right here becomes 1. When t equals 0, that becomes 1. So then C of 0 is equal to 50,000 times 1 minus 2,000. Well, what's 50,000 times 1? 50,000. What's 50,000 minus 2,000? 48,000. So this is our y-intercept. So it says, which graph is this function? I'm just going to graph this in my graphing calculator. Okay, so turn your graphing calculators back on. Go to y equals. Clear that out. I got to clear this out too. So I'm going to put 50,000, 50000, close parentheses, 0.9, close parentheses, open parentheses, close parentheses, raised to the, we're just going to use x instead of t, it doesn't matter. And then minus 2,000. Oops, not 20,000, 2,000. All right. Now, I'm going to graph this, but I know it's going to be some big numbers. I know that my y-intercept is 48,000, so I've got to set that in the window on my graphing calculator. So I want you guys to click on window, look up at the screen real quick. I want you to click on window. Our x minimum is going to be 0, but our x maximum is going to have to be 60,000 because I want it to fit All right, my y-intercept, it's going to cross at 48,000, so I'm going to go a little bit above that. I'm going to go to 60,000 on my y-axis. Now my x-axis, or I'm sorry, no, my x-axis doesn't go to 60,000. My x-axis goes to 20. I'm sorry, I got confused. My y-axis goes from 0 to 60,000. Good thing I caught myself, huh? This goes from 0 to 60,000. Now there's two reasons that I set up this question this way, or the graph this way. One, I know in the y direction it crosses the y-axis of 48,000, so I wanted to go a little bit above that. Well, how did I choose my x value? Well, my base is 0.9. So that means my curve, I know in my head, because this is less than 1, I know in my head that if I go to graph this thing, like this is the x-axis, this is the y-axis, that it's going to start off really high up here at 48,000 and then it's going to taper down. So my x doesn't have to be that far. Okay. So 0 to 20 is fine because it's going to go down quick. So anyways, now that I've got that set, let's go ahead and just graph this and see what we get. Okay. So let's hit trace. I want to see what it is when x equals 20. Because there's a lot of graphs that look like that. So it's about 4,000. I wonder what it is when x equals 12. It's about 12,000. So I'm just gonna, that's a little clue on how you can figure out what the right answer is. So I'm gonna take a screenshot of this bad boy. When you go to do this problem online, there's a clue. When x equals 12, y equals 12,000 or close to it. And then don't forget that my y-intercept here occurs at 0, 48,000. One we solved algebraically, one we solved